Imagine this. One day, you walk into a beehive and it's nearly empty. The queen is there. The baby bees are there. There's food, but the worker bees? Gone. Vanished. No trace, no goodbye note. Just gone. This strange phenomenon is called colony collapse disorder, and it's shaking the very foundation of our food system. Let's break it down. CCD first captured global attention in the winter of 2006 to 2007. Beekeepers in the United States reported losing 30 to 90% of their hives within a single season. These losses were unprecedented, with about half of the affected colonies showing this disorder symptoms without any known cause. Though similar bee disappearances have been noted and nicknamed disappearing disease or spring dwindle in the past, 2006 marked the start of CCD as a recognized phenomenon. By early 2007, scientists formally named it colony collapse disorder amidst a drastic rise in U.S. hive collapses. Soon, alarming reports emerged from Europe as well. Beekeepers across Western and Southern Europe had actually observed unusual colony declines since the late 1990s. What began in North America quickly became a global concern, with CCD-like disappearances later reported in parts of Asia and even Africa. Soon this mystery had become a worldwide bee crisis. Despite intensive research, no single cause of CCD has been pinpointed, but experts believe it's multifactorial. Some of the leading suspects are: number 1, pesticides. Neonicotinoids, modern insecticides, especially neonicotinoids, are neurotoxic to bees. These chemicals can disorient bees and impair their ability to return to the hive. Next one is pathogens and parasites. Bees face a gauntlet of diseases and parasites. A top menace is the Varroa destructor mite, an invasive external parasite that latches on honeybees and sucks their hemolymph, bee blood, weakening the bees and transmitting deadly viruses, like deformed wing virus in the process. Number 3, malnutrition and monoculture farming. Bees need a diverse diet of pollen and nectar, but modern agriculture can create food deserts for them. In landscapes dominated by monoculture crops, like endless fields of corn, cotton, or rice with few wildflowers, bees may only have a single pollen source or forage gap after the crop bloom. Poor nutrition from limited or low-quality pollen can stunt bees' immune responses. Another two are environmental stress and climate change. Now you might thinking, okay, no bees means no honey, that's all, but that's not how it works. Honeybees and wild bees are indispensable pollinators in our ecosystems. By ferrying pollen from flower to flower, these busy insects enable plants to reproduce and bear fruit. In fact, nearly 1 out of every 3 bites of food we eat depends on animal pollinators, and bees make up the vast majority of those pollinators. About 70 of the top 100 food crops grown worldwide, from apples and almonds to coffee and cocoa, rely on pollination by bees or other animals. This means bees are directly responsible for a large portion of our fruits, vegetables, oilseeds, and nuts. Beyond agriculture, bees also help wild plants reproduce, supporting entire food webs and maintaining biodiversity. Simply put, when bees thrive, ecosystems thrive. That's all for today. Thank you.